So today I want to talk about a new product that I've developed that I'm just super excited about. It's called the EMP Alert. And what it is it's a small plug-in device that plugs into an outlet either in your home or RV or wherever. And its purpose is to detect when a nuclear EMP has occurred or when a large solar coronal mass ejection has caused the power lines to reach dangerous levels for your home. So it monitors both the actual physical power lines, the conducted lines, as well as the radiated environment around. So in other words, the air, it's looking for that electromagnetic wave that's coming in. So what it does when it detects such an event is it sounds an alarm to let you know that such an event is occurring and you need to take appropriate action. Now, what appropriate action might be is up to each individual. Certainly one thing you'd want to do right away is hurry to the breaker box and open the main breaker on your house. Now, the reason you do that is it would help to prevent the incoming conducted surge that might be a result of an EMP or a solar coronal mass ejection, all right? The E3 event, the long duration event. Now, many people don't talk about that portion of an EMP very much because it's extremely hard to protect against, all right? Any surge protection device that I know of that's on the market will burn up from the E3 very quickly, maybe within milliseconds, all right? Once you exceed the turn-on voltage of the surge protector, it just goes up in smoke, all right? So surge protection devices that you buy for your home, even the best quality ones that you can get, the ones I have on my home, they're not meant to survive a long duration energy pulse on the lines, right? So they'll burn up under that scenario. So the best you can hope for is that you get a warning before your surge protector kicks on from that E3 event. So that's the idea of the EMP alert. It would give you the warning, hey, there's something going on, the power lines are coming up in value. You might not know otherwise. You hurry out to the breaker panel, you throw the breaker, and that disconnects your home from that surge of energy that would come in from the power lines. So it's an extremely useful product. I would say it's as important as the surge protector itself because it gives you warning that something's going on, all right? An EMP normally, most people will never know that it's occurred until it's already well over with, all right? So that's what the EMP Alert does. And today what I'm gonna do is a brief demonstration of how it might work. Now, I have a couple of ways of demonstrating that. One is I'm going to create the voltages that might be on your house wires, which is normally 120 volts RMS AC, all right? And I'm going to show that the device will sound an alarm when the voltage levels either get too low or too high, okay? Either one, you want to know that your voltage levels on your house have gotten out of spec and that they may cause damage to your appliances and your equipment. Even low voltages can cause damage, all right? So we want to have some warning that that's occurring, that E3 type event is underway. All right, so I'll demonstrate that with the power supply. And then I want to demonstrate a radiated pulse detection. In other words, you know, the big E1, E2 pulse that comes from an EMP. I want to show that the device will sound an alarm for that. And I don't obviously have a full-size EMP system here where I could generate an EMP. But what I do have is I have a very small handheld pulse generator. And basically what it is it's a spark gap generator. It creates a high voltage spark, and when that spark fires, it goes through a little antenna and it generates a little mini EMP. All right, now you wouldn't detect this, 10 feet away, but when you're within close proximity of it, you'll get the EMP type pulse. All right, it's not a perfect mimic of a true nuclear EMP, but it's a pretty good facsimile just to give you an idea. So what I'm going to do is I'm going to power up the unit and then I'll fire this little mini EMP generator and I'll show that the device sounds. All right, so those are the two demonstrations I'm going to do. Okay, so the first thing I'm going to do is I'm going to take the EMP Alert and plug it in. And this is just a prototype unit, okay? The final unit will be a little bit fancier, a little bit more professional. But it's a fully functional prototype unit of the EMP Alert. I'm going to go ahead and turn on the power supply. Now when I do that, you'll hear a beeping sound, a temporary beeping sound, which is really just it's put in there to tell you, hey, the unit is active and there's not something defective about it. It's kind of a, hey, I'm here and I'm working properly. So I turn it on. You hear a beep as it first turns on, all right? Now, that beep says I'm up and running and the unit is functioning and it doesn't detect anything out of the ordinary, all right? Now, I'm gonna remove the front of the device so you can kind of see what's inside. I have one opened up here, but I'll scoot that out of the way and I'll just open up the front of this. I left the cover loose where I could just pull it off. So you get an idea of the complexity of the device, all right? I designed this personally. I think it's as simple as it can be, but it's also a little bit complicated to get work properly. So it has some indicator lights, the green lights, indicating that portions of the circuit are up and going. And now what we want to see is when I change the voltage level outside of an acceptable range, we want the unit to sound and to sound an alarm and stay on until the level drops back below. All right, now those levels are completely settable by essentially the values you put inside of here. So if I want to dial up the voltage here, I can go over and I can dial it up, and we don't want it to sound every time the voltage goes up or down a few volts because you'd be constantly wondering if an EMP is happening. But we do want it to sound when the voltage levels get abnormally high. Now I arbitrarily set this to be something like 160 volts. Again, that number can change very easily, and we'll have the right numbers in the final production units. All right, so I'm gonna go ahead and turn this up. So 130 is still doing fine, 140 hasn't done anything. Go to 150. When I go to 160, it fires an alarm. It says, hey, the voltage levels are too high. And you can see an indicator light also turns on to tell you that you've reached an overvoltage condition. All right, as you dial it back down, it will turn off. We go back to nominal voltage, right? Now again, the purpose of it is to warn you that the voltage levels on your home have risen dangerously high and they might be starting to cause damage to equipment. That tells you, hurry out and open the main breaker on your panel. Okay, that's trying to protect you from the E3 event of either a solar coronal mass ejection or a nuclear EMP. All right. Now it does the same thing on the low voltage as well, and you can dial it again to any level you want. Right now I don't have it dialed down too low, so around 110 volts it kicks on and says, hey, now I've got a low voltage condition. So again, something is wrong with the power at the plug. We need to go out and open the main breaker because again, low voltage can be harmful too. All right, so that's how this detection works of the conducted line. All right, the actual wires in the house, if there's a levels on those rise or fall too much, it will sound an alarm. All right, now next I want to show you how the radiated detection works. Okay, so what I do is I take my little mini EMP generator. Again, this is very low power, and I'm going to just show that when I get it close to the unit and I push this little button here, will actually basically fires that little spark, which causes a little EMP to be generated. You'll hear the device sound an alarm saying, hey, I just detected a very brief pulse. Now, the time that alarm sounds is configurable in the device. I can make it for what I want. I set it for about between 1 and 2 seconds. So it'll be a temporary warning that, hey, something just occurred. Okay, you don't want to just keep sounding forever, but you want to warn them that something just occurred. And then shortly after that, as the voltage levels start to rise on the line, it would turn on fully and just stay on. Okay, but I'm just going to fire the EMP first just to show you what it does, right? So I get the unit close to the part and I fire it, and it fires the alarm. All right, again, it sounds a temporary alarm that says, hey, something's not right. We just received a high energy pulse through the air. You should be aware there could be an event like an EMP has just occurred. Okay. This is trying to simulate the E1, E2 pulse, all right, the radiated pulse through the air, all right? Now, the unit will actually detect if that pulse gets on the incoming power lines as well. Even if the radiated environment was really weak, maybe you're in an area that's shielded, right? So you've got mountains all around you and you don't get the radiated energy, but the power lines get corrupted with that pulse. It also monitors the power lines too for brief pulses, and it will sound an alarm in the same way as it just did here. So one really great question that people might ask is, well, wouldn't the EMP alert be damaged by the EMP or the solar coronal mass ejection? And the answer is yes, it would be if it didn't have protection built in. But I specifically put in a number of components to help it survive both the E1, E2, and E3 that might occur due to an EMP, as well as any rising voltage levels that might occur due to a solar coronal mass ejection. So it's quote unquote a hardened product. It's a product that's not very likely to be damaged at all. All right, and so that gives you some assurance that, hey, when the EMP occurs, my unit's not just going to fail on me and not give me a warning. So again, this device, the EMP Alert, detects both conducted and radiated pulses that are E1, E2, and it also detects long duration E3 pulses that go above or below the normal levels on your power lines, and it tells you, hey, an E3 event is occurring, you should go open up your breaker panel. All right, so that's how it works. That's just a quick demonstration. Of course, if you have questions, you can feel free to send them to me. I'm happy to answer them.